Hello everybody, this is problem 123 again, and in today's episode we're gonna solve this problem named Sansa and Xor. Remember that Xor is short for exclusive OR. I like this problem because it involves a quite interesting property about Xor, about exclusive OR, that we gotta take into account sometimes. So let's see, we have that Sansa has an array and she wants to find the value obtained by storing the continuous subarrays followed by storing the values thus obtained to determine this value. Of course, at first we can think of the quadratic solution for this problem in which we calculate the sort of subarrays, but of course that is not going to work because they're not gonna give us a problem that easy, you see, and it's gonna be at most 10 to the power of 5. So a quadratic solution doesn't work for this problem. Let's try to look for another solution. So this is where we apply the property that I was telling you before. Okay. We have properties of exclusive OR. We have commutativity. It means that A XOR B is equal to B XOR A, but that doesn't matter for this problem. What we care about is associativity. This problem, this property says that A XOR B XOR C is equal to A XOR B XOR C. In other words, we can actually get rid of the parentheses and it doesn't matter. Okay, it's like sum. We can get rid of the parentheses with no problem at all. Okay, that's good that we can get rid of the parentheses because if we want to calculate the value of the answer for this array, we can actually just imagine how the operation will look like and then apply XOR, but we don't have to care about the parentheses. Okay, so how we're going to compute this value quickly? Okay, to answer quickly, we just have to take a look at this test case that we have right here. So basically they are taking the array 1, 2, 3. That's the sample array 1, 2, 3. So at first they take the all the subarrays of length 1, then the subarrays of length 2, and finally the only subarray of length 3, and then they get the XOR. But as I told you before, you can actually just get rid of the parentheses, and that will not affect our answer. It will still be 2. So this problem is transforming into something else. Well, remember that a number XOR the same number is going to be equal to 0. Okay, A XOR A is equal to 0. 1 XOR 1 equals 0. 2 XOR 2 equals 0. So if we count the number of numbers 1 that we have in this array, in this decomposition of length 1, length 2, and length 3 subarrays, we just have to count the number of ones to be able to know if we are either taking that number or leaving that number, because we don't care about those numbers that appear an even number of times in this decomposition that we do right here. So let's count. We have 1 repetition of number 1, we have 2 and 3. So we have an odd number of numbers 1. So we are taking number 1. But what about 2? We have 1, 2, 3, and 4. So we don't take number 2 at all. Now let's see number 3. We have 1, 2, and 3 repetitions of number 3. So we are taking number 3 as well. So the answer is gonna be 3 XOR 1, or 1 XOR 3 as you wanna say it. And remember that 3 XOR 1 is equal to the answer that they are actually giving us. You can actually apply the same analysis to this other test case, which is 4 pi 7 5, and you're gonna prove to yourself that this is true. You just have to count the number of repetitions of each number. In this decomposition, of course, the number of repetitions of that number within all the possible subarrays. Okay? So now our problem is transforming into how many times is this number going to be repeated when I consider all subarrays of a given array. And that is pretty easy to count. We're gonna see how, and we just have to take that number. If it is going to appear an even number of times, and leave that number if it is going to appear an odd number of times. Okay, so let's see the code for this problem. It's right here. So we have first of all, and it's gonna be long because remember that it's gonna be at most 10 to the power of 5, and we're computing Gauss sum here until 10 to the power of 5. It's gonna be 10 to the power of 10. That's why I'm using long. Okay, so basically this variable temp is gonna tell me the number of times that a certain number, I mean this number right here, the ith element of the array, is going to appear in the decomposition that we see here, this one, in which we take length 1, length 2, and length 3, and so on. Okay, so first of all, we consider all possible subarrays. Okay, we're not counting the number of times that it appears, but counting the number of subarrays in which it doesn't appear. Okay, because it's easier. So we are gonna, here is where we are counting that, and then we just subtract that from what we had previously, the total number of subarrays. So the number of subarrays in which it doesn't appear to the left side is this one, and we do the same analysis for the right side of this element. We just have to make sure that we subtract 1, because remember, the number of elements to the right of this array, I mean of this element, is going to be n minus I minus 1. Okay, and then we decide either we take or don't take that number. Remember, if it's odd, if it appears a odd number of times, we have to take it. Oh, sorry. And then we just return ans, and that's it. That's basically the code that we have to do, and actually it gets accepted. Oh, well, I guess you cannot see that right now, so I'm gonna submit it again, whatever. You're gonna see it passes all test cases, as you can see. The 13 that's test cases. Okay, so that's everything for today, you guys. I hope you enjoyed this video. I hope this was useful for you to understand the exclusive OR. This problem was actually very refreshing. I'm talking about refreshing my mind because I didn't remember the properties of exclusive OR, so it made me realize that this is an important property that I should take into account more when I solve problems. Okay, so see you guys in another video. Share this video with everyone on this set, and bye bye.